Introduction to polynomial functions. The equation of a polynomial function. The general form of a polynomial function is f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1, and so on and so forth until you get down to a1 times x plus a naught. Now all of those a's, sub n minus 1, all the way down to a sub 0, are constants. All exponents must be non-negative integers. The degree of a polynomial function is the highest power that you see of the variable. Let's look at some examples to determine whether or not these functions are polynomial functions. So in example 1, we have several parts. Determine which of the following are polynomial functions. If so, state the degree. If not, explain why not. Part A, f of x equals negative 1/2 x to the 5th plus 3x to the 4th minus 9x cubed plus 2x squared minus x minus 7. In looking at all the powers of the x, they are all non-negative integers. So yes, this is a polynomial function, and its degree is 5, because that's the highest degree that we see in x. Part B, g of x equals the cubed root of x. Well, we could write this with a rational exponent. This would be equivalent to g of x equals x to the 1/3. This is not an integer. It's positive, but it's not an integer. So no, this is not a polynomial function. The exponent is not an integer. Part C, h of x equals negative 6x to the 4th times the quantity x plus 2 squared. So yes, this is a polynomial. All the degrees of x are whole, non-negative integers. We could look at this a little bit more clearly before we determine the degree. This would be negative 6x to the 4th times x squared plus 4x plus 4. So if we distributed the negative 6x to the 4th, we would get negative 6x to the 6th minus 24x to the 5th minus 24x to the 4th. So we can just see that the degree is 6. So yes, degree 6. Now we could have done that without actually expanding and multiplying. We see a degree of 4 here and a degree of 2 here. So we know when we multiply out that binomial, it's going to have the highest degree of 2. So we just have to add that 4 and that 2 to come up with 6 without actually multiplying. Part D, f of x equals the rational function x minus 2 divided by x cubed plus 4. So no, this is not a polynomial function because it is the quotient of two polynomial functions. It's a rational function. So simply we'll just say no, this is a rational function.